Hi, welcome back. In step 2, we are going to prepare training and test datasets. We will create a data frame containing all the training data's spectral reflectance properties and the length cover class information. First, we are going to use the extract function in order to extract the spectral reflectance values from the Sentinel-2 bands. Then we use the s.data.frame function in order to load the extracted data into the object TA, which simply means a training area. The training data TA will contain spectral reflectance values from the Sentinel-2 bands. Please take note this code takes a bit of time to run depending on your computer specs and the amount of training data that you have. Right, so if we simply run this code, we are going to extract the spectral reflectance values into our TA object. Next, we want to create a plot showing the mean spectral reflectance values from Sentinel-2 bands. So here, this code is quite long, this chunk of code, so I'm not going to go into details. However, our main objective here is just to create to get the mean values from all the Sentinel-2 bands. Right, so if we run the code, we will get our spectral reflectance profile from the Sentinel-2 bands. Right, next we want to create a data frame that is going to contain all the training points and their corresponding spectral reflectance values. This training data set is the one that we are going to use for modeling. Okay, so we are simply going to create the training data using the data.frame function. Right, so if we run this code, and then next we want to check the whole structure of our training data set. So we are going to use the SRT function. So let's run this. Right, the output shows that we've got 1911 observation with 10 variables. Okay, so these 10 variables have got the response variable, which is the length cover class, and then the 9 predictor variables, which are the 9 Sentinel-2 bands. Right, so the class, okay, the response variable class has got 6 length cover classes, such as the bay areas, built up areas, cropland, grass open areas, woodlands, and water. Okay, the 9 predictor variables has got the following bands: band 2, band 3, band 4, band 5, band 6, band 7, band 8, band 11, and band 12. Right, next we want to check if we have missing values in our training data. So we are going to use the complete.cases function to check for the missing values. Note that this is important because some of the machine learning models cannot handle missing values. Okay, so I'm just going to run this code and then we check if we have the missing values. Right, the result shows that we only have a true. So this means that we have complete cases, and therefore we don't have any missing values. So this is a good news. So next, we are going to use the create data partition function from the current package in order to split training data into training and testing data sets. We will use 60% of the training data as training set and 40% as a testing set. The training set will be used to find the best model parameters and check the initial model performance. The testing set is going to be used to check the model accuracy. Okay, so in order to do this, we are going to set the seed. I have set my seed at 27, but you can choose any number. Why do we need to set the seed? This is because we want to get repeatable results. So setting a predefined value using the set seed function will allow us to get a repeatable result. So this is very important. Right, so let's run this chunk of code. Okay, then we've just finished. So this is all about step 2. Okay, so thank you very much for watching this tutorial. Please subscribe to my channel if you want to get notifications when I have a new video. I will see you in the next tutorial.